Hi everybody, here is the video for the chapter 10 review, and chapter 10 was all about circles. So here are your keys to success. Okay, be able to draw a diameter, a tangent, a chord, and a secant. Okay, know that a radius and tangent meet in a right angle. So if you have a circle and you have a radius and this is your tangent, okay, this angle is going to be a right angle. Okay, you definitely need to remember that. Know that if a radius is perpendicular to a chord, then the radius bisects the chord. So if you have a circle and you have a chord, okay, and here's the center of your circle. So if you draw a radius and you make it perpendicular to the chord, okay, this isn't a great drawing. This will be 90 degrees, and these two sections of the chord will be equal. Okay, the chord will be bisected. Okay, know that if a radius bisects a chord, so if you're given a circle with a chord, okay, and here's your radius, and you're told that it bisects this chord, so this side is equal to that side, then you know that it is perpendicular. So these two work together. If you know one, then you know the other. Okay, so know what inscribed and common tangents mean. Okay, inscribed means it's drawn inside. Okay, and common tangents mean that they're two circles that share a tangent. So if you have two circles and they have a tangent that goes between them, then this is a common tangent. Okay. Know the ice cream cone rule. So remember we had these figures that look like ice cream cones, and these lines were tangent to the circle, then this length was going to be equal to that length. Okay. Know how to find the measure of an arc. So the measure of arc is in degrees, and remember that when you have an arc that's made from the center of the circle, okay, the number of degrees in the vertex is equal to the measure of the arc. When you have an arc that's created by a vertex on the circle, then the arc measure is equal to 2 times this, and we'll go over that, this vertex, and that'll go, we'll go over that in a little bit, but definitely remember the difference between the two. So know how to read and write the standard equation of a circle, and we'll go over that. And now know how to graph when you're given the standard equation of the circle, how to graph a circle. Okay. So these are just examples. So this is a diameter. Okay, a diameter goes edge to edge, edge to edge, and it goes through the middle. Okay, a tangent ray, okay, it touches at one point. It's kind of hard to see what point it is, but it touches at one point. Okay, and if you draw the radius, it will be a right angle. Okay, so draw a secant. Here's a secant. So it's like a chord, except it goes on forever. Okay, it is not through the middle. Okay, here's the center piece sitting out there all by himself, and the secant is nowhere near it. Okay, a chord is similar, except it only goes edge to edge. And it too, just like the secant, does not go through the middle. So make sure you know the difference between these. Okay, and also know what we just talked about a minute ago. If you draw, a line that is perpendicular to that chord, these two sides will be equal. The chord will bisect. And then conversely, if somebody tells you that, that these two pieces are equal, meaning that it bisects, then you know that this angle is a right angle. Okay, so there's two ways to look at that. So make sure you understand what the difference between these are. Okay, so use the diagram to determine if the statement is true or false. So number 5, the distance between the centers of the circle. So the centers of the circle are A and B, and we're looking at that distance, is equal to the length of the diameter of each circle. So if I was to compare, if I look at the diameter here, okay, so this is a radius, and this is a radius. Okay, it makes sense that the distance between the centers, if I just shifted it over so it touched the edge here, and it touched the edge here, okay, obviously it would be equal if I shifted it over this way and put the ends of the line here and here. So this is true. Okay, I'm going to erase these marks. Okay, lines y equals 0 and y equal 4. Okay, so you got to get straight what is the y equals 0 line. So that's going to be all numbers, all coordinates where y is equal to 0. And that's going to be this line right here. It's going to be the x-axis. Okay, and y equals 4. So this is all numbers, all lines, the line where y is equal to 4. So y is equal to 1, 2, 3, 4. Here's this line. That's the line y equal to 4. Okay, and this states that it represents all the common tangents of the two circle. And there's no way that that's true because this isn't even a tangent. Okay, if I had drawn it up here at y equals 6, you could make an argument that maybe. But the key word here is all. Whenever a statement uses the word all, you need to be suspicious because all means all, like every single possibility in the universe. And it's very hard to get that in mathematics. Okay, so always be suspicious if you see an all and you're being told whether or not, you're being asked to tell whether or not it's true. If it says all, it's probably false. Not all the time, but there's a good chance. Okay, the circles intersect at the point 6, 3. So here's point 6. The x-coordinate, 1, 2, 3, 4, 5, 6. The y-coordinate, 1, 2, 3. And yeah. Okay, this is their intersection point. So that one's true. Okay, suppose the two circles are inscribed in a rectangle. And here's that word, inscribed, in a rectangle. Okay, so how would you inscribe these two circles in a rectangle? So that means the two circles are going to be inside the rectangle that you draw. So you already have these two sides of the rectangle, and then you're going to complete it. You're going to draw this line and that line. Okay, so the perimeter of this rectangle is 36. Well, let's see. So remember, perimeter is the fence around the rectangle, and the length of this side of the fence is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So the length of that one is 12, length of this one is 12, and on the y-axis is 1, 2, 3, 4, 5, 6. So this length is 6, this length is 6. So the question is 12 plus 12 plus 6 plus 6 equal to 36? And yes, it is. So the perimeter of the triangle is true. Okay, don't multiply 6 by 12. That's the area, and that's not what the question asked for. So make sure you know the difference between perimeter and area. Okay, now these are just a simple application of the Pythagorean theorem, which you guys are very familiar with at this point. So here you're asked to find, in number 12, you're asked to find x. So you have a right angle. Okay, you have the lengths of two of the sides, so this is a perfect example of the Pythagorean theorem. Now, you're going to have to set it up carefully. Remember, the longest side is the hypotenuse, so that's your c squared. So if I have my Pythagorean theorem, it's equal to a squared plus c squared. Okay, this is c squared is going to be equal to 100 squared. Then I can put x in the a position, and 96 squared in that position. If you can get this setup done correctly, you're pretty much home free. So x squared plus 9,216 is equal to 10,000. These numbers are pretty big, but that's okay. X squared, then you subtract 9,216 from both sides, you get 784. You take the square root. Okay, x is equal to, you pop square root of 74 into your calculator, and it turns out it's a nice even number of 28. Okay, 13 is the exact same thing, except here we're looking for the hypotenuse. Here's the hypotenuse, the longest one. So here's my Pythagorean theorem. Okay, I'm going to have, let's try 45 squared. Plus my other leg, oops, is 108 squared equals x squared. Okay, 45 squared, get your calculator out, plus 108 squared is 11,664. And that is going to equal to 13,689. So it's equal to x squared. We're going to just take the square root of both, and x is going to be equal to 117. Okay, I'm going to let you do 14 on your own. It's pretty much the exact same thing as these. Okay, here's some ice cream cone problems. And remember what we said at the beginning, that if K and M are the points of tangency, okay, that means where the tangent touches the circle, okay, and you have this point outside there, the lines, these two lines are going to be equal. So it becomes pretty obvious on how to find x. So we're going to set 4x plus 7 equals to 7x minus 8. We're going to subtract 4x from both sides. That's going to get 3x here. And we're going to add 8 to both sides. You're going to get 15. And obviously x is equal to 5. Okay, easy peasy. So number 19, we have 3x squared minus 10 is equal to 17. 3x squared, add 10 to both sides, is equal to 27. Divide both sides by 3, x squared equals 9. Square root of x squared, square root of 9. Okay, x is equal to 3, or remember, it can also be equal to negative 3, because negative 3 times negative 3 is 9. Okay, so you actually have two answers for for this. Okay, I'm going to erase this because this one gets a little bit longer. And this is a review of your algebra. So we have 2x squared plus 3x minus 2 equals 3. Okay, we're going to simplify that. We're going to say 2x squared plus 3x. We're going to subtract 3 from both sides. That's minus 5, and that's 0. So 3 minus 3 is 0. Minus 2 minus 3 is minus 5. Okay, so now we can make so you'd have to play with this a little bit, but let's try x minus 1 and 2x plus 5. Okay, and then, so we have two answers that make this equation true if x can be 1, or 2x plus 5 equals 0, 2x equals negative 5, x equals negative 5 over 2, or negative 5 over 2. Because if I plug in negative 5 over 2 for x, this will become 0, and the whole equation becomes 0. If I plug in x equals 1, this part of the equation will become 0. 0 multiplies anything equals 0. Okay. So that's a little bit of a tough one, but because you're having to factor a quadratic. But that I just wanted you to see that to remind you about it. Okay, find the measure of the given arc or chord. So here, you're asked for the measure of BC. So you're asked for this measure. You're given the measure of AB. So what do? So the key thing to remember here is the total number of degrees in this circle is 360. So if I subtract 116 degrees, I have 244 degrees left. So this whole measure here is going to be 244. But I only want this measure, the BC measure. Well, then I would notice that this line and this line are equal. So these sections, both their arc measures, both have to be equal. So we can find the measure of one of them, i.e. the BC one, by dividing by 2. It's 122 degrees. Okay. So number 2, we want the measure of LM. Okay. And we notice again that these 4 sides are all equal. So that means all these individual arcs have to be equal. And there are 4 of them. So we take 360 degrees and we divide it by 4. And we get each individual arc is equal to 90 degrees. Okay. So here in number 3 is a good example of a chord. And we're given that that chord is perpendicular to a diameter. So we know that this side is going to be equal to this side. Okay, that diameter is going to bisect that chord. And so this side is going to be 11 because this side is 11. 11 plus 11 equals 22. Okay, those are pretty easy if you remember that those rules. Okay, so number 4, we're looking for the measure of, of AC, and this is similar to that first one because we know that this arc is equal to 130. So if we subtract 130 from 360, we're going to get 0, 3, 2. Yep. Okay, and we notice that this side is equal to this side. So it means that these two arcs have to be equal to each other. So we can divide 230 by 2. And we get 115. So one of those two arcs is going to be, I guess I want AC, 115. Okay. Okay, so we're given the measure of PQR. Okay, first you have to find out what you're given. There's PQR is equal to 80 degrees. Oh, no. We're given that PQ is equal to 40, and we're asked for the PQR. Now, we're given also that this chord is bisected by this diameter. Okay. We know that this is 90 degrees, so that diameter also bisects that arc. So this part of the arc has to be 40 degrees, and 40 plus 40 equals 80. Okay. So 6 measure of KLM. So the tricky things with these is making sure you understand what they're asking for. So they're asking for KLM. So we know the total circle is equal to 360 degrees. So we can subtract this part here, minus 142. 10 take away 2 is 8, 5 is 4, 218. And then we can subtract this part off here, minus 38, 0, 8, 180. And we're left with this part equaling 180 degrees. Okay, remember a few simple rules, and these aren't bad problems at all. Okay, these are a wee bit trickier in that you have to find x, and the only way to find x is to figure out a relationship between 3x plus 16 and 12x plus 7. Okay, here is that rule that we talked about earlier. So you have a diameter, and you're told that the angle between that diameter and the chord is 90 degrees. So we know that these two pieces, okay, that the diameter bisects the chord, and these two have to be equal. So we set 3x plus 16 equals 12x plus 7. Okay, 12x minus 3x is 4. 16 minus 7 is 9, right? 16 minus 7 is 9. Yep, messed that up. 12x minus 3x is 9x. 16 minus 7 is 9. X is equal to 1. Okay, let's look at number 8. So here, again, we're looking for these two lengths here. Now, we're given that these two chords are perpendicular to these two lines coming from the center, and these two lines are also equal. So that means that these two chords have to be equal. And we have 3x minus 11 equals x plus 9. Okay, 3x minus x is 2x equals, add 11 to both sides. 11 and 9 is 20. X is equal to 10. Okay, and here, same thing. So we have a diameter that is 90 degrees to a chord, so that we know these two sides have to be equal. So 9x minus 3 equals 7x plus 5. Okay, 2x equals 8, x equal 4. Okay, now this guy is a little bit tricky. So they want you to find the measure of P, oh, sorry. I don't want an angle, they want an arc. So PQR, PQR. Okay. And you're given that this measure here on this angle is 75 degrees. So you'll notice that okay, that this is a straight line. So if this angle is 75, then what does this angle have to be? Well, the sum of angles on a straight line is going to be 180, so we have 180 minus 75. Okay, 10 to the 5 is 5. Yep. 10 to the 5 is 5, 7. Okay, so it ends up with 105. And now, okay, so we know that this angle here is equal to 105. Now remember what we said, that if you're measuring an angle that goes from the side of the circle, okay, and you're looking for its arc, you have to multiply this angle by 2. So I'm going to multiply 2 times 105 is equal to 210, and sure enough that is C. Okay? So you had to remember that if you have the vertex of the angle on the circle, the arc is 2 times the measure of the angle. If the vertex of the angle is in the center, and this is 15 degrees, the measure of the arc is going to be 15 degrees. They're going to be the same. So there's a big difference. Okay, so here's an equation of a circle. And you need to remember that the equation of a circle looks like this. X minus h squared plus y minus k squared is equal to r squared. And h and k are going to be the center. Okay. And r, as always, is equal to the radius. So they give you a circle, and then they give you a selection of possible equations, standard equations, and you have to pick which one is right. So the easiest thing to do, we know the center is equal to 1/2 negative 2. Those are the coordinates. So if we put that into the circle form, we get x minus 1/2 squared plus y, and since this is a minus 2, this becomes a plus 2, and that's equal to r squared. Okay, so right away, that tells us the only one that has that configuration, x minus 1/2, y plus 2, is b. Okay, so we don't even have to calculate the radius, which you would have to do by finding one of these lengths. Okay. So, but you don't even need to do that. You just need to plug in the right numbers in the right way. Okay, notice that one of the possibilities had the opposite, x plus 1/2 and y minus 2. So if you had forgotten that the standard equation called for a minus, okay, x minus h, y minus k, you might have answered C, and that would have been wrong. Okay, so make sure that you know the equation of a circle. Okay, so here you're going to write the standard equation of the circle with the given center and radius. So remember, our general equation is x minus h squared plus y minus k squared is equal to r squared. Okay. Excuse me. H, k is my center, and r is my radius. So if my center is, okay, so my center is minus 4, so my equation is going to switch it and make it plus 4. and my y coordinate is just 7, so it stays negative. My radius is 6. I'm going to square it, equals 36. Okay, and for this one, okay, my x is 3, so my equation becomes x minus 3. This is minus 9, so it's y plus 9. Radius equals 8.4 squared, which is equal to 1.414. Oop, nope, I was looking at the wrong one, sorry. Thought that looked goofy. Okay, and this is equal to 70.56. Okay, so those are pretty easy, just plug and play. So now you're having to look at the equation, okay, and then graph it. Okay, so you're having to look at the equation, then you're having to graph it. So if we look at this equation, we see that our center is going to be equal to positive 3, positive 2, okay, and 1, 2, 3, 1, 2, sure enough, okay, and my r is going to be equal to the square root of 1, because remember this is r squared, okay, square root of 1 is 1, and sure enough, my radius is equal to 1. Okay, and they drew it there in pink. So let's interpret number 22. So my center is going to be at 4, because I have x minus 4, and I have y plus 4, so my y coordinate is going to be equal to minus 4. Okay, my r squared is equal to 2, so r is equal to square root of 2. Okay, so 1, 2, 3, 4. Negative 1, 2, 3, 4. Okay, I've got my center, and the square root of 2 is equal to 1.414, and which is obviously 1 and a little bit, which is 1.414. Okay, so that's it for chapter 10. And again, if you have any questions, please let me know.